have discussed in my previous video countable set and 1 corresponds. Let's some introduction about countable set again. At first, let's see the 1 correspondence. Two sets A and B are said to be 1 corresponds if there exists one mapping A onto B. Have you understood? Okay. If A and B are finite, then cardinal number of A equal to cardinal number of B. What is cardinal number? I have introduced in my previous video completely. But if A and B are infinite, then there is no sense taking the number of elements. If A and B are infinite, then cardinality are same if there exists 1 corresponds. Have you understood? Okay. For any integer, any positive integer n, let Zn equal to set of elements 1, 2, 3 n and Z equal to 1, 2, 3 set of all positive integers. Okay. For any set A, we say 1. A is finite if A equivalent to Zn for some n, which I have introduced in my previous video completely. Here I only introduce just definition. A is infinite if A is not finite. Okay. 3. A is countable if A equivalent to J. 4. A is uncountable if A is neither finite nor countable. Okay. Five. A is at most countable if A is finite or countable and countable sets are also known as denumerable set or enumerable set. This is just definition. I have introduced in my previous video completely. Just see my previous video. Okay, right. Let's see some theorem of countable set. First theorem. If A1, A2, A3 are countable set, then prove that n equal to 1 to infinity an is countable, or countable union of countable set is countable. Have you understood? Okay, let's see the proof. Given that A1, A2, A3 are countable set. Have you understood? Okay. So the above set can be represented as A1 equal to, suppose A11, A12, A13, A1n dot. Okay. A2 equal to A21, A22, A23, A2n dot. A3 equal to A31, A32, A33, A3n. Similarly, An equal to An1, An2, An3, Ann dot. So on. Have you understood? Okay. We have to prove n equal to 1 to infinity an is equivalent to natural number. Now consider the elements in the above expression the sum of subscript is 2. That means there is only A11. That means here A11, because consider the sum of whose subscript is 2. Now find the element the sum of whose subscript is 3. There are 2 elements. A12 and A21. Have you understood? That means A12 and A21. Similarly, we can find 3 elements A13, A22, A31. How? The sum of whose subscript is 4. Have you understood? That means this is A31, sum of whose subscript is 4, A22, A13, etc. So on. Counting in this way, for any positive integer m greater than equal to 2, we can find m minus 1 elements, the sum of whose subscript is m. Have you understood? Okay. Now we can list the elements of union n equal to 1 to infinity an in the following way. Have you understood? Okay. Let's see the following way. First A11, then A11 maps A12, A12, A21, and then A31 goes to A22, A22, A13. Have you understood? Then A31 map A14, A14, A23, A23, A33, A33, A41. In this way, we can count. Now, counting them in order indicate by arrow. Have you understood this arrow? Just see again. Now we can rewrite the element of n equal to 1 to infinity an according to the sum of their subscript. Have you understood? Okay. Now n equal to 1 to infinity an equal to a11, a12, a21, a13, a22, a13, a1n dot dot. Have you understood? Now construct a bijection map. If from n to an. Have you understood? Oh. How the bijection map? A11 will be first element. Have you understood? A12 will be the second element. A21 will be the third element. Have you understood? A31 will be fourth element. A22 will be fifth element. A13 will be sixth element. So and so on. This is the way of bijection. Okay. Now see the mapping F from n to n, where n equal to 1, 2, 3, 4, 5, 6, so on. And sorry, here not n, here n equal union of n equal to 1 to infinity an. And union of n equal to 1 to infinity an equal to a11, a12, a21, a13, a22, a13, etc. And there exists one correspondent. How? Just one map a11, 2 map a12, 3 map a21, 4 map a13, 5 map a22, 6 map a13. Have you understood? Okay. That means there exists 1-to-1 corresponds. If from natural number to union of n equal to 1 to infinity n. So, union of n equal to 1 to infinity an is countable. Okay? Right.